Because I see only got 2 participants. Okay.
Good morning, good afternoon, good evening, good night. I'm not sure where you guys are, but thank you so much for joining us today on our webinar. My name is Kim Everhart, and I'm a member here of the marketing team at Percona. And I'm excited for you to join us. We have Peter Zaitsev, our CEO, who's going to talk to you today about open source DBaaS and Kubernetes. So, before we kick this off and get going, I'm going to go through a few housekeeping items with everyone. So everybody is muted, but we welcome questions. So if you have questions throughout the course of the presentation, feel free to drop them into the Q&A window, and we will answer them at the end of the presentation. And before I turn this over to Peter, I'm going to also do a sound check and a visual check with everyone. So if you can hear me, can you please raise your hand icon? Awesome. So many hands going up. So that means you can hear us good. So I'm going to lower your hands, and then I am going to ask Peter to say a few words and make sure we can hear him too before we get going with this. So Peter, can you say hello to all of these wonderful people?
Hello, all the wonderful people.
Wonderful people. Can you hear Peter? Raise your hand up. Oh, I see hands going up too. Oh, so many hands. Awesome. So everybody can hear you. They can hear me. So let's do one final check. Can you see the screen? There should be an opening slide talking about our topic for today. And the hands are going up there too. So Peter, they can hear us. They can see our deck. And I think they're going to be ready to listen to what you have to say. So one last note before I turn it over to Peter. We are recording this. So if there's any reason you have to leave early and you can't make it for the whole session, we will send you a recording within the next 24 to 48 hours. And you can pick it up where you left off and also share with your colleagues. So Peter, with that, I'm going to let you take the stage.
Yeah. Okay. Well, thanks, Kim. Hello, everyone. And indeed, Zoom just works. Let's get started. Well, let me start by talking about the early days of the modern open source software, at least as it looked from my perspective. I got involved with open source in the late 90s. And the open source at that was, I think, a lot different than it is today, at least from their complexity standpoint, right? I mean, if you were looking to use open source in those days, in many cases, you would have to download the sources, maybe find a couple of patches which make them work in your environment, right? Find the proper compiler version and a tool chain to get that compiled. And then, a few hours later, if you're lucky, you have compiled that awesome piece of software you want to use, right? And since that times, we really got a lot of simplification in their general technology, but in an open source software as well, right? We got the binaries, packages, repositories. Now we have a lot of self-contained software like which you can use Docker, Snap, and so on and so forth, right? And we can see that as a never-ending move to simplicity, right? Because, well, all of us want to spend more time on what is actually our the work or fun objective and less time on that kind of overhead, right, if you will. So really what you have in this case, trend of making things easier and reduce your barrier to entry. So you have a lot more people who can participate in a open source. But also what is interesting in this case, that means what most developers right now, even in the open source space, they don't really touch the source for a lot of the open source they use, right? And even for something as basic as a Linux operating system, building that kind of from scratch from resources would be something most of developers never done and would not be comfortable doing if they have to. So again, I think that is a really the great thing. That simplification, it really allows us to use more complicated, more valuable, more productive software. Really allows us more developers in open source space, because more people can can participate in that. You don't have to be kind of hardcore C++ developer, right, and understand all it is and building some system plumbing to participate in open source. But I think that is where we also have a problem or a dark side when it comes to the open source. And it comes with what, if you look at the next round of simplification, where we are really moving a lot of that software to the cloud, can come with a really vendor lock-in, which happens in the cloud, which is really the opposite of the ideas of open source on so many levels, right? So if you really look at the current state, what would be the easiest way to deploy a lot of open source software in a most easy to consume, most integrated way? Well, that's most likely going to be in the cloud using some proprietary API, which really works only with that cloud vendors, right? Now, in this presentation, we are talking about database as a service, right? And that is obviously how we use database, this kind of API in the cloud as it applies to the databases. And database as a service is really great on so many levels, right? It really allows to remove a lot of toil and allows you to really take away things like managed availability, database patching. You don't have to care about the backup. It really takes some, basic performance tuning, right? At least if you're running MySQL, you wouldn't be running that with default, right? So it is all great, but the question would be is, well, can we get all that public cloud database as a service in simplicity, but really as an open source solution, which does not require all that lock-in? Well, before we get to that, let's talk about what exactly do we mean by the open source and database as a service, right? Because many people think about a database as a service is what cloud vendors provide, and that is kind of proprietary by default. Well, this is not how I think about things, right? I think the database as a service, as an idea, has a couple of components here. Some of that is really their interface and the way you interact with that, right? Like instead of conventional way to deploy database software where I install a lot of packages, configure backup, high availability, and so on and so forth, right? I essentially can interact with a piece of software with an API, right, to provision high-level objects such as a database clusters, which really take off a lot of toil on themselves. They self-update, self-tune, have a self-healing if some components goes, and so on and so forth. Really, this is something which is a software can do, and that is what open source database as a server is, right? Now, then there is a management piece, right? So for example, if you are running, let's say, Amazon RDS or Amazon Aurora, in addition to this kind of very nice software which has out there, if software doesn't work, if something fails on behind, Amazon actually has a people which will go out there and fix it. So you as a user don't have to deal with that. And frankly, you don't, right? Because if you have Amazon RDS, you do not have a shell access to look into that and deal with corrupted database, right? For example, for many reasons. And that is not just about the open source. That is, in this case, about getting people involved, but that is where you can have a choice. Instead of having, as in a cloud case, only some high priests which work with cloud vendors being able to help you to resolve problems on your backend, you can choose to do that yourself or bring in a choice of partners if the whole solution is open source, and you can pick how open that is. Now, what I find it's very interesting with a cloud is what when cloud was not so ubiquitous as it is right now, and it was not it wasn't understood as well by many people. Many cloud vendors would compare cloud computing to electricity by analogy, right? And you can see this is a slide from one of the earlier presentation of Amazon Web Services, right? And that is a great analogy, I think, how we should be using the cloud. Remember, one thing about electricity is it is pretty much commodity. In many places, you can choose, let's say, to buy more or less reliable electricity. You can buy green electricity if that is something you are passionate about, right? Or if you really want to be independent, you can actually run your own generator and produce your own electricity, right? And those are available from many vendors, right? And when you buy appliances like your fridge or your microwave, they work with all that electricity together, right? Now, what cloud vendors really provide you, though, is something completely different those days. Their intent is, oh, it's kind of like electricity, but you know what? When you buy the fridge, it's only work if you buy electricity for us. That is what the things like Amazon Aurora, DynamoDB, Spanner, and wherever it is, right? So when a cloud vendors used to compare cloud to electricity, now if you look at kind of so-called best practices, right? How Amazon training, for example, teaches you to architect the best cloud systems is to use as many of those extremely proprietary solutions to lock into their platform completely, right? Now, with all that marketing and training information you gain, I think you have to remember what in the end, the choice is yours, how you are going to use and deploy the cloud, right? And how much lock-in you are going to embrace. Now, I spoke a lot about this open source and a choice and how things are going with usability. While you have the choice, I would say having the open source database as a service, which is comparable to those very proprietary cloud solutions, then bad news is what we are not there yet. The good news, though, is what we are having a lot of happening in the ecosystem, and especially around their Kubernetes ecosystem, which allows us to enable all those solutions. What Kubernetes is, the Kubernetes is a fantastic foundation for the cloud, which really allows us finally to build solutions with a unified API, which work on variety of nodes on a whole large-scale clusters, same as decades ago, Linux enabled us to do that on the individual host, right? And with that, it has a lot of momentum, and it's also universally supported in public, private, hybrid cloud, right? So if you are really building up your software on a Kubernetes, you have a lot more of ability to move your workloads between the different solutions. At least, of course, if you choose, if you're testing that, and if you're sticking to really the Kubernetes features rather than those extensions which all the platforms would provide. Now, the challenge of Kubernetes, which I think is still exists in the ecosystem, is what Kubernetes was initially designed to run stateless application, right? And in the early days of Kubernetes, especially, running databases in Kubernetes was really not a good idea at all, because Kubernetes didn't like stateful application, and well, database is exactly their quintessential state, right? You want to store your stuff in a database and make sure that does not disappear, right? And there are still people who think that databases on Kubernetes are not a good idea. And there are use cases indeed when a database on Kubernetes can be more hairy or more complicated, right? Like, for example, if you are looking at the extremely large database instances, right, they are much better run in virtualized environments, right, or even bare metal, when there is a lot of less chance to say, oh, you know what, this port is going to be go down, right? Please figure out, right, how to shift that workload load somewhere else. Which can be, inefficient with large data sets. At the same time, there is a lot of stuff which appeared in the Kubernetes in the last few years, which enables that. We have a stateful sets, we have a persistence volume, we have an operator framework, which is this automation framework, which really allows you to incorporate that complicated logics, which databases often have to behave, right? Like when you are upgrading the database cluster, for example, you just cannot push and update all the packages on the cluster together, right? Or just update a node, and if it doesn't work, roll it back, right? Because often maybe that new piece of software introduces some incompatibilities on the data on your state where old versions would not run, right? So you really have that architected and orchestrated in a very deliberate fashion. How do you do database clusters updates, right, for example? And that is one of the things we can finally do with the operator frameworks. What you can also see with Kubernetes right now, there are multiple public clouds, right, like CockroachDB Cloud, InfluxDB, PlanetScale, which have disclosed that they're using Kubernetes as a backend, right? So really, there are at least hundreds of thousands, or probably millions of database instances running those days based on Kubernetes. And we have also similar experience among our customers, right? We have a number of customers which are going on in with Kubernetes, right, and running a lot of databases on Kubernetes with a lot of success, right? In many of them, that adoption is, I would say, is not complete, right? And it's kind of going from your kind of like a least critical test and dev databases all the way to their mid-scale databases. And I think maybe we do not have a complete penetration, right, for the most business critical databases just yet, right? And I think for a good reason, because there is some work to do both on the Kubernetes level as well as on the operators what Percona provides. Right, so at this point, our work in this space has been focused on the operators, essentially for MySQL and for MongoDB. Our operator for Percona XDB cluster, right, even that while name doesn't say that, that is actually Kubernetes solution what I'm saying, MySQL compatible solution, which is 100% open source, and really which offers you this kind of a very strong consistency and availability, which is what you want to have in Kubernetes, right, and which makes things much easier in a Kubernetes case when you do really expect that some of the nodes may need to be rescheduled at any time. Now, you can also deploy that as a pretty much MySQL replacement as a single node if you want the database for developers. What we are looking in this case is the direct users of Kubernetes operators, right? Which can, you just go ahead, install the operator on the cluster, right? We provide a Helm chart for installation, right? And just use it directly. And also we are looking for the other kind of user, right? Which want the service level experience, right? Similar to what Amazon RDS provide. And the fact that the Kubernetes is in the backend is less relevant for them, right? They just want the database which takes care of itself as much as possible and removes as much toil. For this, we have a two piece of software we have written. One is Percona Database as a Service CLI, and that is our experimental solution, right? Which once you set it up, can provide people with CLI command line kind of interface for people who don't understand Kubernetes a lot. So for this, I will do walk through how it works with a Google Kubernetes engine, and it's also worked with the Amazon engine, right, and others. But this is was their one to show easily, and I think what Google Kubernetes engine is really very good Kubernetes out there among major clouds. So what do you need in this case for this to work? Well, that is a free components I would expect, right? You need a kubectl, which you typically need like for wherever you talk to Kubernetes. You need a good G-Cloud SDK, which is helpful if you want to talk to Kubernetes on the Google Cloud, as we're going to do. And then you need the Percona Database as a Service CLI, which is to do with Percona stuff. Right. So as you look at that for all the three components, you just would go ahead and install them. I like installing using native package management, if you like, from repositories, because that allows us to very easily get the updates of the packages when they are released, right? If you look for Google Cloud SDK, that pretty much works the same. You just need to install well, install a Google repository, right? Here is what you would do to get a database as a service CLI. You can see here we have a little bit additional step, what you need to enable experimental repository, right? Because this is experimental product, right? And we want to make sure you do not sort of mix things which are kind of fully support GA quality and experimental stuff by accident. So we require that extra step, right? So to set things up, if you want to G-Cloud, you obviously need to log in, configure a project, what you're going to operate in, and then you can deploy the Kubernetes cluster you want to work with, right? In this case, for test, I'm getting this very small cluster with a free nodes, right? Obviously, for production deployments, you would have something larger. Getting the kind of control, security in place, right? For my additional user management, right? Okay. And then we also configure their namespace in which we are going to work, right? And in this case, you have kind of a little bit of extra complexity, if you will, right? So we have a project, which is a Google Cloud concept, and you deploy Kubernetes cloud, Kubernetes cluster in in that project, and then inside Kubernetes cluster, you may have multiple namespaces in which you would operate. So once you have done that, right, you can pretty much spin up a database with a single command. Of course, there are some additional commands to configure to specify number of nodes, right, or how powerful node you want to do, right, and some others. But if you really want something for a very simple stuff, right, then you can do it with one command. Now, one thing which you need to know if you are not advanced Kubernetes user is what when you are working with deploying something in Kubernetes, by default, it will not be exposed outside of that Kubernetes cluster, right? So in your case, as we have installed, let's say, kubectl on our laptop or some other host where we want to use as a driver, then we can use a port forward command, so we can map our local port to that external cluster, right? We can run it in the background, and as if we've done that, we can connect to MySQL using the local host, right? And that will be port mapped to our Kubernetes instance. Well, you can tell me, well, that is all great in this case, and that can be good for development if I'm running my own tools from a lab. So, but what if I want to access this solution from the other node, which is not running inside of that Kubernetes cluster, which I just deploy for database purposes, right? Well, in this case, we have an options what you can pass this option of proxy SQL service time type equals load balancer, and it will create as external resource endpoint. And in this case, you will just be able to connect to that directly with your favorite client or wherever you are, your application you are using. The next thing what you may notice here is what on this provisioning case, and then also the other example I provided, is what we are using their random root password, right? Which is just generated by the tool which provides it. Well, this is the choice we made, kind of not to have the default password, which is kind of hard-coded in an application, because that is not a good idea. And so many of the security hacks, right, in everywhere just happen because there are some default passwords which are static and shipped with whatever, like software and hardware, and people just forget to change them, right? So in our case, by default, if you choose not to specify a password, we'll assign password to you, but that will be random password. If you want to create the database with a specific password, well, then you can actually pass the password, right? If you as you want. And the next example covers that use case of a single node deployment, right? So as I mentioned, by default, we are providing you with this reliable cluster, which should survive a single node failure, which may happen in a Kubernetes, right? And I think especially in a Kubernetes, that is how you should be running your production. But if you're really looking for something for development, maybe you just having a database which is provisioned for your developer pipeline or something like that, you don't need all that kind of stuff. And this tool also allows you to provide that single node. We are you can see in this case is what you're saying, hey, I configure the PXE cluster of a size of just one node, disable proxy SQL because, well, I don't need really proxy SQL if I only have one load. But also what I need to do is explicitly set the option to allow unsafe configuration, right? Because that configuration is unsafe. And if you don't do that, well, you won't be able to start the cluster with just a single node, right? So that is what we have in the database as a service. Now, even more fresh of a press, we have started building the graphical user interface for this in PMM, in Percona monitoring and management, right? Where you can actually use a GUI to provision the cluster for MySQL and MongoDB with a few clicks. That is like a rather early feature preview version, right? So don't use it for production, but we would very much encourage you, if you're interested in having the open source database solution, to give it a try. Let us know what works well, what doesn't, what we should change, because frankly, it's a lot easier to change the software before it has became generally available. And also, that is an open source project. So besides your ideas and testing, we also would appreciate your code though too. So with that, to sum it up, what you can maybe not, while we're not completely there, I know from us and also from other vendors, we are starting to get some ideas about what the open source databases would look like, and I am quite sure what we will get out there. Give it a try. And if you look at from my take, I believe a database as a service has really won, and that will be leading course that we are going to be consuming the databases in the future, because it really gives us an unparalleled convenience of using database compared to other vendors. At the same time, software vendor lock-in sucks. And really, as usually, we have open source coming to the rescue in such cases as it have done before in number of instances. With that, that's all I have. I only want to remind you what Percona Live is coming online again. Unfortunately, due to the pandemic situation, we won't be able to have a live version, but market calendar for attendance, and also call for papers is open now. So I would very much encourage you uh, to submit your proposal for a conference. And also, uh, I know this webinar was shifted in time at the very last minute. I see there are many of you who were able to make the time still, but I am sorry for some mix-up which required that very last minute change. With that, thank you, and I would be happy to answer questions.
Excellent. Thank you so much, Peter. And I echo Peter's sentiments. We do apologize for the last minute change, and we always strive to keep our schedules tight. So I appreciate your flexibility in joining us today. So Peter, there has been quite a few questions that came through. So let me get those over and we'll start asking them. So how is the Percona operator different from other operators?
Well, that is a good question, right? What operators would you want that to compare that to, right? If you look, as I mentioned, we have operators for MySQL and MongoDB. In this case, I think uh, MySQL with PXC, I think what we have some of a more mature operator, right? At least what we would like to have that, which has number of advanced features like live upgrades and point in time recovery. Right. If you look at their MongoDB space, that is not where there are a lot of operators out there which exist. Right. There is a lot of stuff which kind of operator which is wrapped around some proprietary tool sets in MongoDB space, right? Where we have an operator which is fully open source.
Okay, and then in the relation to that same question, they wanted to know, do your operators automatically configure PMM for instances where it's provisioned?
Well, in the recent version of operators, the PMM or like PMM version 2 is supported, right? But that is something what you would configure as you provision the operator. What you want nodes to kind of register and report the stats to the appropriate PMM version.
Okay, so does Percona DBaaS use K8 annotations for some tasks? If I use it on self-hosted bare metal K8 clusters, not on a public cloud, am I missing something that Google Cloud or AWS would provide?
Well, yeah, so I'm not really sure, right, what folks what you mean in this case in terms of K8s annotations for some tasks, right? I mean, unfortunately, I am not the level of the same expert, I would say, in the details of a Kubernetes implementation as I know MySQL. Now, if you look at their self-service bare metal versus public cloud, our intent with all of it is to make sure it is as usable in their bare metal implementation as it is right on the public cloud. But there are some differences. Like, for example, if you look in the backups, in many cases you would use like S3 compatible storage, which is available right there on Amazon. If you have your own implementation, well, you probably will have to roll out Minio right on something else like that yourself, right, to be able to use that functionality.
Okay, so we had a couple more questions. In a master-slave cluster, how long would it take to fail over to another master?
Okay, so if you look at our setup, right? So just to make sure, we only support their PXC, right, or Galera replication if you want with this synchronous / virtually synchronous replication, right? And that is exactly to deal with that issue, right? Depending on the configuration, right? That should generally takes a few seconds for proxy SQL, right, to discover what that node is not available anymore and remove that from rotation. And then I think there's good other question for that we have from Marco, where we have plans to support the async replication, right? And yes, we do, right? So we do have a plan to support async replication. Now, some of you may wonder, okay, well, why are you going with some more advanced stuff as Galera replication and PXC and not starting with async replication? Well, the question in this case is if you look at asynchronous replication by itself, it's not very good at automatically handling many failure modes. In a lot of cases, that's kind of in the MySQL world would require the operator intervention, if you like, right? And with PXC, it was designed exactly to avoid that to begin with, right? So while on the surface it may look simpler, actually getting the all the edge cases and kinks work out from async replication support is tricky, right? But in the end, we do have plans to support different topologies, which includes MySQL group replication and classical async replication. What we also are working on is making sure what you can use a combination. Like number of people, for example, ask us to say, well, you know what, I want to have like a PXC cluster deployed in this kind of given region, right? Maybe across multiple availability zone. But then I also want to replicate using asynchronous replication of that cluster to some DR site, right? Very complicated, very common use case, right? And that is, some of the things that we're working on right now.
Great, thank you, Peter. We had another question. What requirements must be met on vanilla private Kubernetes cluster for your tool to be able to work? Is there an expected storage class, etc.?
Well, we wanted to make sure, right, it works on as vanilla as possible, right? Like for the experimentation, it can work all the way to their things like Minikube. We also have their operator certified on OpenShift Red Hat platform. In terms of the storage class, it supports multiple classes, right? One thing in kind of open source do-it-yourself case, we have done a lot of testing with OpenEBS. They have some, pretty cool stuff both for local and shared storage.
Okay. Does Percona have an operator for Postgres?
Okay. So we do not have a Percona operator for Postgres as of yet, but making sure we do have the offerings, right, for Postgres is on our roadmap.
Excellent, great. With Kubernetes and persistency, our main burden was to provide strong consistency in failover situations with traditional relational databases and automatic failover, failback. Is Percona aiming to provide these settings on Kubernetes with your operators?
Well, I mean, that is exactly, if you will, what we are putting a lot of work on, right, to make sure what we do have there the consistency in handling the failure situation. Now, if you look at the consistency model, right, that is something what we inherit from the database, right? Like the consistency model, for example, for Percona XDB cluster and for MongoDB is different. And also actually all of them have some configuration how you can play with consistency model, right? And on the what we support that. What you want to make sure happens in Kubernetes is what you do indeed have is self-healing, kind of automated failover and feedback. You can make sure you don't have a data loss situation and so on and so forth, right? And all in the Kubernetes environment, right, which has slightly different expectations.
All right, thank you. Would you say Galera-based cluster with multi-master cluster is a good fit for a very busy WordPress or WooCommerce site? Galera, I'm not sure if I said that right.
Oh yeah, so sorry, I just had this like, oh, what, for some reason my screen sharing got stopped. Not sure why. Okay. Okay, so if you look at their Galera, right? I mean, we have it used, right, for those use cases. But when it comes to Galera, there is a lot of variety in how you really how you deploy it, right? Because some people who deploy Galera, let's say, in their single data center, right, a multiple availability zone with a good network and a fast storage, they have a very low overhead, which comes with this kind of concept of asynchronous replication, and which can be even work for write busy applications, right? If you are at the same time, say, deploying Galera on a global global kind of use case, right? With different nodes in different regions, with poor network between them, then often you will have significantly worse latency, right? And that's when people say, well, it doesn't work, right? I'm much better off with a standard MySQL replication.
Okay, so we had another question.
Yeah.
Are we good? Okay. Why are we not extending OpenStack Trove to advance open source DBaaS?
Okay, yeah. So let me, I think I had also a couple of other questions. Let me target those first as I'm looking at them. So yeah, so Mark, I see was pushing on their Kubernetes annotation for load balancer address and so on. I actually have to follow up with that with our development team, right? I do not know the answer. And then Marco is also asking about the possibility of Kubernetes becoming lock-in in the future. Sure, right? Well, I think the interesting thing about the Kubernetes, right, and what makes it interesting in this case is what where Kubernetes and related technologies they come from the cloud native foundation, which is not a single vendor, right? But there is a lot of interest kind of coalesce uh, on that foundation, which has less risks of some dramatic changes, such as license change or something like that. But what happens in those cases, it does is what you also have different vendors. They compete on creating their own flavors or distributions, right? Like if you think what happened with Linux, like, well, there is Linux, of course, but there is a Red Hat Enterprise Linux, which Red Hat positions as, well, better Linux, right? And it has some additional features, right? And so on and so forth, right? So, but that lock-in is much smaller when it comes with proprietary software, and you also can avoid that, right? So if you don't want log in with, as a Linux example, well, just make sure your software is not only working with Red Enterprise Linux, but also works with Debian, right, and others. And also, I will believe, as with the Linux case, we are going to have some more kind of proprietary Kubernetes distributions with some sort of a vendor extensions and stuff, right, as well as more open community distributions, right, which would not have those, right, and you just have to be careful how much of those kind of proprietary bells and whistles we use, and the choice will be ours.
Okay, great. Thank you, Peter. We do have a couple other questions that came through the
Go ahead.
chat. Okay, so do you have a website for testing functionality similar to PMM?
So I'm not quite sure what that's for testing functionality of what. I mean, I do not really understand that.
Okay, we'll redirect to that one. If you're still on the call, please, if you want to add some clarification, we'll bring that back to Peter afterwards. There was a question about persistent storage in Kubernetes. Can you say a little bit more about that and how it's implemented in DBaaS?
Yeah, so if you look at the persistent storage and Kubernetes, we look at, we do support both their local node storage, right? And that's kind of fantastic if you have some, very high performance NVMe, right? As well as their shared persistent storage, right? Similar to EBS in the cloud, for example. And how exactly you engineer that? Well, that kind of depends on you, right? And your use cases. One thing, for example, we do not recommend you running is saying, well, if I am running single node on my local storage, right, then that's typically is a pretty dangerous idea, right? Because if you have a crash, right, you may lose that storage, and recovery may be harder compared to your kind of a VM of a bare metal use case. And I would answer also the other related question about the large database sizes, right? What data size is considered large? Well, I think a lot depends on your both requirements and what exactly the sizing of the Kubernetes, right? And your network speed and so on and so forth, right? I would say as a ballpark figure, their number is like maybe 1 terabyte, in size, right? What we use as a kind of guesstimate, but a reality number is will depend, right, on your kind of operational needs and also on size of your environment. And what I would recommend in this case is to make sure, well, you actually test things, right? Make sure before you decide to move a databases, test a similar amount of load and so whatever in a Kubernetes environment to see to what extent you are comfortable.
I think that's just about the end of all of our questions. We did have one fun kind of question at the end, which is somebody wanted to know what kind of headset you use. It has a great voice quality.
Oh, is it? It's called like a game concept, right? Which is nothing big. Well, I think the magic thing here is called the wire, right? So that is not like a Bluetooth headset, which can be subject for additional interference, right, or something, but it just using the wired headset with their microphone, which is not on the side, right, or something, but in a proper position. So yeah, otherwise I think it's like a $30 microphone from Amazon, right? Nothing fancy here.
Hey, sometimes those are the best ones. So that was the end of our questions. So thank you guys all for joining us. Peter, thank you for your time today. I would drop the link in our chat for you guys. If you use our software, we'd love your feedback. So there's a link where you can come in and give your opinion, and we'd love to hear that. And we hope to see you at some next events. And of course, if you're interested in speaking at Percona Live or attending virtually, check that out. And we look forward to seeing you there and seeing you next time. So everyone have a great day. Thank you, Peter.
Okay, thank you, everyone.
All right, bye-bye.
Bye.